at least. Okay, so 4, is that what we're doing? Okay. Well, you should have your sheet in front of you. Yeah. Okay. So this is about piecewise functions, okay? So you don't really have to do all this graphically, but I just want to go over the concept one more time as to what's really going on here. So this is 1, and let's say this is 5. Then if you take a look at this equation here, okay, that's going to be represented by a line that's going like so, right? It's got a negative intercept, an intercept of -2, a y-intercept of -2, and the slope is about 1. Okay? So here's my x, here's my y. Then it's saying the other piece of this function is this guy here, for x is greater than 5. And you want to make it continuous. In other words, starting out here, it's got to have the same value as what the blue guy has. Now the function might be going up like that, might be going like that, I don't know. I don't know until I find c, because c is going to be the slope of that line. You guys get me on that? But you do know that this red circle and the blue circle should have the same y values. Okay? So for the red one, can you tell me what the y value would be? How would you even get it? How would you get the y value for the red one? At the point x equals 5. And what do you get? Wait a minute. You plug in 5 where? I said I want the red one. So, sorry? So what do you get? Did you just get 5c minus 3? You're plugging in 5 for x? Yes? Now for the blue one, Leo, for the blue one, what do you get? 3. Okay, because isn't it asking you to find c? So c is equal to 6 over 5. So it's going to be a line that looks like that, okay, not this one here. Okay, you guys all right on this stuff?
So all we did was plug in x?
That's all we did.
Wow.
But I want to make sure that you guys understand the concept as to pictorially and graphically what it means. Okay, just plugging stuff in is pretty unmathematical. That's not nice, okay? Plugging stuff in and not understanding things is totally useless, okay? It's totally useless. Okay, number 4, and then next. Number 6, okay? Okay, 6 can be done in a very smooth way, okay? Really nice, cool way. And it tells you that. Okay, it tells you it is possible to do this problem without the quotient rule. So I'll do this without any explanation, and you guys see if you understand it. Do you understand the square root of x is x to the 1/2?
Yeah.
Then when you divide, what do you do with exponents? You subtract. So 2 minus 1/2.
Oh.
3 over 2.
We're not going to use the quotient rule?
Well, it says it is possible to do this problem without the quotient rule, so I'm trying to show you how to do it. Okay, is everybody with me on this? Everybody there? Yes? And then it becomes really easy. Right? Straight out using the power rule. You guys with me on this? Yeah? And now you're going to kind of simplify and do things. Maybe I shouldn't say simplify. I should say beautify. Nice. Next time it's going to be beautify. Okay? So don't cancel this 4 and 2 here, okay? Because I want the denominator to be, well, actually, you know what? Let's go rewrite this as 3 over 2 times square root of x minus 4. My bad. Well, don't just copy it without understanding it, okay? See what I'm doing. And I do mess up, so what's the big deal? Okay? Huh? What? Sorry? It's x to the half. It's not one negative half. Right? Okay. And so now you're going to put everything on a common denominator, which be, hang on, 2 root x. Question, Teddy? Because this is not a minus. That's not a minus. So now you're going to cross multiply. And then this guy becomes 3x minus 4. And that's your answer. That's your final answer.
Way off.
Okay. Well, do you see where you have to... Did you use a quotient rule? You can see if you use a quotient rule, it gets a little ugly. Right? Well, the quotient rule, I mean, you can use a quotient rule, but then there's much more algebra with that. Much more algebra with that. Okay? Guys got that all right? Number 7?
Yeah.
Okay. Okay, number 7, maybe you didn't understand the language. All it's asking you is find dw by dz. Remember, a derivative is a rate of change. It's a rate of change. Okay? Remember, it's rise over run. It's the slope of your tangent line. So you're going to write it as 7 over 3 times z to the negative 2. This is equal to 7 over 3 z to the negative 2. Yes? And you know how to differentiate this. What do you get? Hello? Negative 14 over 3 z to the, which is equal to negative 14 over 3 z cubed. So maybe it's a language you didn't understand. Rate of change. Rate of change is a derivative. That's what derivatives mean. Okay, you guys all right there? Kauri, you have a question? Okay, everybody got this problem down?
Yes.
Okay. Next.
9.
9.
And 8. 8 and 10.
Okay, I'm not going to do 8. What's the issue with 8? It's straight out of your cheat sheet. What's the derivative of CSC? And derivative of cotangent theta. That is the answer. There's not much. There's no trig identities. That's it. That's it. There's no trig identities that'll get you anywhere with that one. This one is not doable. There's nothing there that'll make it beautified. Yeah. So this guy can't go to the salon. Okay. Okay. All right, next one be 9. Next one be 9.
Yes.
Okay, what's the issue with that? I thought you are a derivative stud.
How do we do it when it's like parentheses something
Inside, outside, inside, outside. Chain rule, chain rule. What's the outside function? What's the derivative of 10? What's the inside function? Sorry, what's the inside function? Sorry? What is the inside function before the derivative? What's the derivative of x squared minus pi over 2x minus, exactly, which is 2x. Yeah, derivative of pi over 4. Pi over 4 is a constant, right? What's the derivative of a constant? 0. Pi is a number, it's a constant. So then this guy becomes 2x. That's it. Just rewrite it. Rewrite it in legal ways. Okay. Kari, was that the one? Kari, was that the one? Okay, does everybody get this one okay? No? Didn't get it or get it? Guys all right?
Okay, so what do you do when you have to divide y prime by y prime? Yeah.
Divide y prime by y prime? What do you mean?
In number 10, you have y prime equals x over x, 1 over 1 plus y prime.